Next up, question 3. So we are given here the two graphs, and the question says that the diagram shows graphs with equations y equal the function f of x and y equal the function g of x. Describe fully a sequence of two transformations which transforms the graph of y equals to function f of x to y equals function g of x. So we're trying to see how does this graph turn into this graph using two transformations. So first of all, you can see that this graph can move to the left in order to get closer to this graph and eventually transform to it. We can actually compare two dots to see how does the graph move. So it's 1, 2, 3, 4, 5, 6. So we're going to move to the left 6 units and come here. You can actually have a quick sketch of the graph to see the graph more clearly. So let's try. So basically, I'm just copying the graph. This is not necessary. I'm just trying to show you guys what it's gonna look like. And yeah, let's write down our first transformation, which is translation by the vector of minus 6 and 0. Because we move to the left for 6 units, if you remember. And now let's look at this graph. How does it become the other graph, the g of x graph? So it looks like it's being stretched, right? It looks like it's being stretched in the way that it's taller, right? So this is called the vertical stretch. Then we have to figure out how much did it stretch. What is the factor, right? So basically, this can be done by choosing 2 points. And we just see the y coordinate of this point. The y is equal to 3, right? And this one is 6. So the factor would be equal to 6 divided by 3, which is 2. So the answer is, it is a vertical stretch by the factor of 2. Next up, question 4. The diagram shows a sector of ABC of a circle with center A and radius 8 centimeters. The area of the sector is 16 over 3 pi square centimeters. The point D, which is right here, lies on the arc BC. Find the perimeter of the segment BCD. which is here. This is what they want to know. B, C, and D. So we're going to start by what is given, which is the sector area. And the formula is the sector's area is equal to theta divided by 360 degrees multiplied by pi r squared, which is the area of the circle. And 16 over 3 pi is equal to theta over 360 degrees multiplied by pi 8 squares. And we're going to get, since the term on the left is multiplied by pi, and the right hand side we also have pi being multiplied here, so we can actually divide both sides by pi, so it's going to be cancelled out. Next, I will multiply both sides with 360 over 64, and the right hand side will be left with theta. And so theta is equal to 30 degrees. We're getting there. So the theta here is 30 degrees. And next we can try to find the BC arc here using the formula, the arc length formula, which is equal to theta divided by 360 times the circumference, which is 2 pi r. That will be equal to 30 degrees divided by 360 multiplied by 2 pi 8, and we're going to get 4 over 3 pi centimeters. So we already know the BC arc length. We have to find the BC, the straight line, the red color here, right? What we can do is we can try using the trigonometry theorem. And now we know that BA is a radius, which is 8 centimeters. We also know that CA is a radius, and it is 8 centimeters. Now we have an isoceles triangle, and we can divide it up in the way that we're going to get 2 perpendicular triangles. The angle here will be split up to 15 degrees and 15 degrees. And basically now we can use the trigonometry theorem. So sine theta is equal to opposite side divided by the hypotenuse side. See, so this is the opposite side, and this is the hypotenuse side. let's do this. So sine 15 degrees is equal to opposite side divided by 8. So the opposite side will be equal to sine 15 degrees multiplied by 8. Now we got the opposite side, and BC is equal to 2 opposite side. So BC is equal to 2 opposite side, which is 2 times sine 15 times 8, right? So we can say that BCD segment is equal to the arc BC, which is 4 over 3 pi centimeters, plus this chunk centimeters, the BC straight line, which is 16 sine 15 degrees centimeters. So using the calculator, we're going to get 8.33 centimeters.